Today we're going to be working on performing operations on radicals. So we're going to start off with addition and subtraction. We're going to simplify if possible, and if not possible, state why. So in order to be able to add or subtract radicals, they need to have the same index and the same radicand. So we have the square root of 27 minus 2 square roots of 3. So first we need to, since our radicands are not the same, let's see if we can simplify and make them the same. So the square root of 27, we can break that up into 9 and 3. The square root of 9 is 3. With the square root of 3, bring down our minus 2 square roots of 3. And then we're going to treat this kind of like variables. We're just going to subtract the coefficients. So 3 minus 2 is 1, so we just have 1 square root of 3. In example number 2, they have the same index and the same radicand, so we can add them together right away. We have 1 cube root of 24 plus 6 cube roots of 24, so we have 7 cube roots of 24. But can we simplify the cube root of 24? What perfect cube goes into 24? That would be 8, and we multiply it with 3. So we have 7. Then we're going to multiply it with whatever comes outside. The cube root of 8 would be 2. Cube roots of 3. 7 times 2 is 14. Cube roots of 3. In our third example, one has an index of 3 and one has an index of 4. Therefore, this is not possible. They have different indices. So let's look at a division problem. The quotient property for radicals says if we have the nth root of a divided by the nth root of b, we can simplify it to the nth root of a divided by b. So here, since we have the fourth root of 80 over the fourth root of 5, we can make that the fourth root of 80 over 5, and then we simplify. 80 divided by 5 is 16, so we have the fourth root of 16. And if you look on your power sheet, we can see that 2 to the fourth is 16, so therefore the fourth root of 16 is equal to 2. And now on to multiplication. We know that for square roots, if we have the square root of a times the square root of b, it's the square root of a times b. So here, if we have the square root of 3 times the square root of 5, that's equal to the square root of 15. So the product property, similar to the quotient property, if we have the nth root of a times the nth root of b, will become the nth root of a times b. So when we're multiplying radicals, anything outside gets multiplied together, so negative 6. The root will stay the same, so it's still a square root, and then multiply the radicands. So we have negative 6 square roots of 216. Then we need to simplify the square root of 216. 216 is 36 times 6. So we have our negative 6 that was already outside. We're going to multiply that with the square root of 36, which is 6. And the square root of 6 will stay square root of 6. Negative 6 times 6 is negative 36 square roots of 6. Number 2, we have a fifth root, so it's going to stay fifth root of everything. 16 and 4 get multiplied. And then when we're multiplying, we add our exponents together. So x cubed times x to the 7th will be x to the 10th. y squared times y to the 6th would become y to the 8th. Z times z to the 10th will become z to the 11th. So now we simplify like we did last class. 64 is 32 times 2. The fifth root of 32 would be 2. And we'll still have the fifth root of 2 left over. How many times does 5 go into 10? Twice, so of x squared. 5 goes into 8 once, with 3 left over. And 5 goes into 11 twice, with 1 left over. We also can have multiplication problems where we have a integer and a radical. So let's practice multiplying those together. We're going to double distribute or FOIL this out. 1 times 3 is 3. 1 times negative square root of 10 would be negative square root of 10. Square root of 5 times 3 would be plus 3 square roots of 5. This one is not under a radical, so you cannot multiply it underneath with the number underneath. It'll just stay outside. Then square root of 5 times negative square root of 10 would be negative square root of 50. Currently, there's no like terms to add together. The square root of 10 is just going to say square root of 10 because there's no perfect square that 10 is divisible by. Same thing with 5. 50, however, is divisible by 25 and 2. So we're going to have 3 minus the square root of 10 plus 3 square roots of 5 minus 5 square roots of 2. Even after simplifying, we don't have any like terms, so we just put a box around it. That's our final answer. That's as simplified as possible. So let's try it again with a cube root involved. 2 times 3 is 6. 2 times negative 2 cube roots of 9 would be minus 4 cube roots of 9. Negative 3 cube roots of 3 times 3 would be negative 9 cube roots of 3. And negative 3 cube roots of 3 times negative 2 cube roots of 9 would be plus 6 cube roots of 27. The cube root of 27 is equal to 3, so we're going to multiply that with the 6 that was out front, bring down our other terms. If we simplify, this is equal to 18, and then we can combine our like terms. 6 plus 18 is 24, minus 4 cube roots of 9, minus 9 cube roots of 3. Since none of these can be simplified or combined as like terms, that's it. That's all for today. See you in class.